Okay, hello. You should see that. You hear my voice? Is everything seem okay?
We hear you.
Okay. Let me start some programs up. Okay. Whoops, wrong button. Okay. I'm just trying to get all these windows set up. Okay. So, okay. Sorry about Tuesday. Um, my blood pressure was going up and down like crazy, and my heartbeat was being really irregular, and they asked me to go to the hospital. So I had to spend a day in the hospital while they tried to figure out why, and they still don't know why, but that was the illness. Um, so we'll see what happens. Okay, so let me think. Uh, we want to start talking about this new renderer today. Um, I'm hoping there'll be a new programming assignment up soon. Okay, so if anyone's still working on the previous ones, you can still ask me questions about them. And right now, there isn't a fourth one up there. I hope a fourth one will be up there real soon. And let's see. So let me show you what this new render is about. I mean, it's about this thing called view volumes and aspect ratio. So let me download this render and also download this zip file on rendering, which has pictures and demo programs in it. Okay, so one thing when we first talked about the camera and projection at the beginning of the semester, we looked at some of these examples like this. See, that create this view volume. So we talked about the idea of the view volume. Okay, the camera sitting, in our case, the camera sitting at the origin, staring down the negative z-axis. Now, what we didn't talk about, what these demo programs let you do is they let you change the shape of that view volume. That's what we're going to start talking about. We're now going to let our render do this kind of stuff, change the shape of the view volume. So here, like I'm moving the top edge, here I'm moving the bottom edge of the view volume, the right edge, okay? And so we want, that's the first thing. Like if you look here, it says that this new render allows us to control the view volume, okay? So this is controlling the view volume. We'll use these same parameters. These parameters are standard in 3D graphics, what's called left, right, bottom, top, near, far. Near is this plane over here, okay? And the way this works is the left edge is the left edge of the near plane. Let's see if I can, doesn't make it really bigger. See how see how the near plane is getting farther from the camera and the near plane is getting closer to the camera. But as the near plane gets farther and closer from the camera, the view volume changes shape. Okay, but if you notice what's not changing is this little rectangle at the front. Let me make it bigger. Now notice as I move the near plane, see that rectangle in the front doesn't change because that rectangle at the near plane is what left, right, bottom, top are. Left, right, bottom, top are there's this axis going down the middle of the camera. How far to the left of that axis you are, how far to the right of that axis you are, how far above it and below it you are at the near plane. So when I move the near plane away from the camera, because it's a frustrum, as this thing moves away, notice that the volume narrows. See how the volume is narrowing as the near plane gets farther away. And the far plane right now is this. Well, I'll make it go real. Yeah, the far plane is as far away as it'll go right now. This little app doesn't make the far plane go any farther. Okay. Okay. So the standard parameters for a view volume are where on the z-axis the near plane is, how far down the z-axis the near plane is. Then at the near plane, you measure to the left, to the right, above, and below, and then you project from the camera through that rectangle. That's our view rectangle now. And we've talked about the view rectangle. Now our view rectangle, instead of being at z equals -1, our rectangle is at z equals near. Instead of being at z equals -1, it's at z equals near. That's the view rectangle. And then the view volume extends out from there. Let's look at another. There's a whole bunch of these little demos that show this thing. Let's look at another one. Maybe it's let's look at another one. Maybe it'll be. Oh, not that one. Let's see if I remember which one. Okay. Here's, see. Oh, oh no, that's actually not the right app. That's, no, that doesn't, see, that's not the, this one's not, this one's controlling the view volume, but not the way we want to. This one does it a different way. Yeah, it shows you the view volume, but in a slightly different way. Instead of showing the left, right, bottom, top. I thought there was another one that showed left, right, bottom, top. Oh, okay. Here's the view volume over here. And here is, notice here it says there's two ways of controlling the view volume: left, right, bottom, top. This one's using the other way: field of view, aspect, near, and far. But if you right click here, you can change it to the other. There. Okay, now it's using left, right, bottom, top, near, far. Okay, so that's left is this number, right is this number, bottom is this number. Notice that in this app, you click on a number and you scroll up and down to change the number. So you click on a number, and as you move the mouse up and down, it changes the number. And there's top. And then there's the near plane. And as you change the near plane, see how the volume is changing. It's, see, the shape of the near plane, the shape of the view rectangle doesn't change. But as it moves away from the camera, the view volume shrinks. Okay. And as it moves closer to the camera, the view volume keeps growing. Notice that this is also making me zoom in and zoom out on the character here. Okay. Let me move the character farther away. Okay. And move the farther back. And then see how I'm zooming in on him, except he's getting cut off because I can't move him farther away. But as I move the near plane, the near plane is connected to the idea of zooming. We'll see that this is, see, I'm zooming in and out on him. But what I'm really doing is, this is not how a camera works. You know, notice that with a real camera, if you get closer to somebody, they get bigger. And if you get farther away, they get smaller. So that's kind of like zooming. But cameras, if you have a fancy camera, you have a zoom ring on it, and that works in a completely different way than what this 3D graphics do. What 3D graphics do is they basically do zooming by controlling this view volume. Okay, when you make the view volume smaller, you're zooming. See, if I make the view volume smaller, I'm actually kind of zooming in on him. Now the near plane's not working. Okay, so what we want to do is let's see if there's one more that I think that is kind of like this. So here's another, down here is a picture of the view volume. Oh, this one doesn't have the left, right. Let's see if it's this other one. Yeah, this one lets me move the camera, but it doesn't let me change the size of the view volume. Okay, I thought this one had the view volume. See, there's the view volume, but this one's just moving the camera, not changing the view volume. Let's see if he had, I thought there was one. Oh, here it is. Left, right. Okay. Okay. Well, that's the one we were using before. It's similar to the one we were using before. So, okay. So they're zooming in, zooming out. See how the volume gets smaller and narrower? I'm zooming in on that ball in the middle. And here I'm zooming out from the whole thing. See, I'm zooming out by making the view volume huge. That's essentially what zooming is in 3D graphics. It's not playing around with lenses. It's just playing around with the shape of the view volume. And it turns out that's how all 3D graphic systems do zooming, is by controlling the shape of the view volume, as opposed to real cameras, which do things with lenses. Okay? So it's a simplistic way of doing zooming, but it works. Okay. All right. So that's one thing we want to do. We want to control the shape of the view volume. Okay. Now, when you control the shape of the view volume, well, actually, I'll bring that back up. Right now, notice that if you can't, this is a square in front, because everything is, it's a half a unit above, half a unit to the left, half a unit to the right, half a unit above, half a unit left. So this is a square, and you see a circle here. Now notice as I change the, now notice what's over here. It's not a square anymore. And over here, I don't see circles anymore. Okay, this is no longer a square. This picture here is a square. And what I'm essentially doing is I'm squeezing this non-square rectangle into this square viewport. This is actually a viewport over here. That's the view rectangle. This is the viewport. The view rectangle is not a square. The viewport's still a square. When you eventually have to squeeze the view rectangle into the viewport, everything gets squeezed and you get ovals. So this is the idea of aspect ratio. Okay, and this is in the page here. It says that the two ideas we want to talk about are the view volume and aspect ratios. Because once you start manipulating the view volume and giving it different shapes, you have to start worrying about what shape does that rectangle have. That's called the aspect ratio. And does it agree with the shape of your viewport? If it doesn't agree with the shape of your viewport, you get distorted pictures. So we have to, as in computer graphics, we have to deal with this issue. Okay. The aspect ratio is defined to be, for any rectangle, aspect ratio is something about rectangles. The aspect ratio is defined to be, it's the ratio of the two sides. And I always forget if it's numerator, if it's the ratio of width to height. Okay, the ratio of width to height. So this is an aspect ratio that's greater than 1, because the width is bigger than the height. That's like a movie screen. Movie screens have aspect ratios greater than 1 because they're longer than they are tall. If I want, I can create the aspect ratio the other way. Go back to being a square. Now move the bottom out this way and the top out this way. Okay, notice now the aspect ratio is less than 1. the width is much smaller than the height. Aspect ratio is the ratio of width to height. So this is a typical aspect ratio of less than 1. This was like portrait pictures. Yeah, like when you take a portrait picture, or when you're in portrait mode, you're seeing a rectangle that's taller than it is wide. Okay, so paintings that are portrait, they call it portrait mode because usually when you paint someone's portrait, you paint this kind of picture. The other one was usually called landscape mode because when you paint landscapes, you want them wide. When you paint portraits, you want them tall. So aspect ratios this is aspect ratio less than 1. That's often called portrait mode. Aspect ratio greater than 1 is often called landscape mode. Notice that right now that rectangle has to be squished vertically. See, it has to be squished vertically to fit it in a square viewport. So notice that the spheres become flat ovals this way. Before they were ovals standing up, now they're ovals horizontally. Okay, because this view rectangle had to be squished in the vertical direction to make it fit in this square viewport. Okay, so we have to see how we deal with this stuff in graphics code. How do we deal with the fact that this thing has one aspect ratio, this thing has a different aspect ratio? What if this aspect ratio looks like this, but we don't want this being distorted? What can we do over here so that this isn't distorted? Because now this has got a different aspect ratio than this one, but there might be something we can do over here to make the picture not distort. Those are the kind of things we want to talk about. How do you deal with the aspect ratio of the view rectangle versus the aspect ratio of the viewport? Okay. Now, remember our pipeline, if you think about the graphics pipeline, oops, let me build the Java docs so we can just read the Java doc in a nice way. Oh, I'm sorry. This one hasn't been updated yet. So I need renderer 5. I forgot that one hasn't been that overview page. I haven't had time to update that overview page yet. So need the overview page from renderer 5. Let me build the Java docs again. Remember, we project to the view rectangle, then we clip to the view rectangle, and then the view rectangle we go from the, well, let me just make a note. Yeah, if you think about the rendering pipeline, you go from a view volume, and then you project to a view rectangle, and then from a view rectangle, you map it to a logical viewport, and then from the logical viewport, you send it to the physical viewport in the frame buffer. Okay, so those are the steps. It's from view volume to view rectangle to logical viewport to the physical viewport. So far, all those steps had the view volume was a square cross section. The view rectangle is a square. The logical viewport. Now, well, the logical viewport isn't always a square. And in your last homework assignment, you saw how when you resized the window, circles weren't circular anymore. So we had this being a square and this being a square, but this didn't have to be a square. When the window, or like, when the viewport here is, say, 600 pixels wide by 300 pixels tall, this guy's not a square anymore. And I could even download the homework assignment, and you can if you remember what it looked like. This is the issue we're going to deal with. What happened in that homework assignment when you oops. Okay. This is a square. The view rectangle, the view volume is a square. The view rectangle is a square, and this is a square. But on the other hand, I can go down here, and now this is not a square, and I start seeing the distortion. Because this program, we didn't know what to do to fix that. Like, what if you wanted those to stay round? Now, in this case, you had the R key, but the R key would chop it would force this thing back to being a square. So this is back to being round because you forced this to be back to being a square. But if now I do this, now that's not round anymore, but I can force it to be a square by just my program resizing the window. But as the user resizes the window, when it's no longer rectangular, this becomes an ellipse and these become rectangles. Okay. But remember, in the programming assignment, I told you that this thing is still a circle. When you pull it back into the view rectangle, it's still a circle because in the camera space, this guy hasn't changed. It's still a circle in camera space. It's appearing as a rectangle here. So what happened was somewhere in this step, it was a circle here, it was a circle here, and it became an ellipse here. The geometric object changed from being a circle, and the circle then became an ellipse here and stayed an ellipse here. Okay, so we want to think about what's happening as you go through the pipeline, how things are getting distorted, and how you could fix it. What might you do to fix this stuff? Okay, like here, one fix, the one we could do in this program was resize the window, but that's kind of like that's not really an optional, a good choice. When a user sizes a window themselves, we would like our program to update itself so that if we want this to be a circle, we would take care of that within this window here, not resize the user's window, but to redraw our screen so that this is a circle and this is a square and this is a square. So we want to figure out how to do it better than like here, either we leave it distorted or we resize the user's window, which in a way, both are not good. Leaving it distorted is not good. Resizing the user's window is not good. Okay, but this, you can see the problem. It showed up in that homework assignment that when you allow the user to resize the window, things become distorted in their shape. And it's because of this. We saw it in the in the demos when we could see the view volume. When the view volume's aspect ratio didn't match the view rectangle's aspect ratio, something had to be scrunched to fit into the other. One of them had to be scrunched to fit in the other one. Okay. Actually, if we go back to that demo, let me show you. Think about it from the point of view of that demo and the program we just ran. Okay, so here's one program. This is our demo. And then there was the one from the rendering folder. Oh, it wasn't that one. Okay. There's you're seeing two sides of a coin here. When I do that, I get distortion. Over here, if I do that, I get distortion. Okay. Oval, a circle became an oval, a circle became an oval. Can anybody see what's there, why these are two flipped sides of the same thing? Now think about our little diagram here. You go view volume, view rectangle, logical viewport, viewport. What's different on the left and on the right? Does anybody see what's different on the left and on the right?
The aspect ratio is greater than 1 on the left.
Well, its aspect ratio is greater than 1 on the right also. See here? See? There's an aspect ratio greater than 1. And here's an aspect ratio greater than 1. So both of them, there's an aspect ratio greater than 1 because it's in landscape mode. And see, this one's also, see, the view volume is in landscape mode. It's got an aspect ratio greater than 1. Okay, so they both have aspect ratio greater than 1. In terms of this sequence, what's different on the left versus the right?
Well, the actual shape of our viewport is changed, but on the right, it's still the square.
Okay, I think you have the right idea, but be real careful. What's different here and here?
Okay, and this one,
This one?
view volume has changed its shape.
Aspect ratio, yeah.
And it's the frame buffer, or our viewport in the frame buffer has stayed the same shape.
Yeah. What happened over here?
Our viewport has changed its shape, whereas its information has stayed the same.
Its view volume has stayed the same.
Yes, there you go.
Yeah. See, there's two aspect ratios: the aspect ratio of the view volume and the aspect ratio of the viewport. Over here, I'm changing the view volume. Over here, I'm changing the viewport. So the problem can come up in either end. See, you could have a non-rectangular, a non-square view volume mapped to a, so this could be non-square and this one's square, or it could be the other way around. This one's square and this one's non-square. On the left, the view volume is still square. Remember, I told you these guys are still circles in the view volume. The view volume is not changing in this example. So the view volume is a square, but the viewport is in landscape mode. Over on the right, it's the view volume that's been changed to its aspect ratio, but the viewport is still a square. Now notice in either case, you still get distortion. For example, if I want to get the ovals, if I want the oval here to look like the oval here, I would go back to this thing. Make this thing back to a square, more or less. There. Okay. See now how I got this one to be an oval, like this one's the same oval? Because now I'm going from portrait mode to a square. And here I'm going from a square over here, to landscape mode over here. And they have the same effect because I'm going from, well, notice that they both gave me ovals here. So I'm going from a what to a what. Aspect ratios are a number, okay? They're positive numbers. The aspect ratio here is what kind of positive number?
Less than 1?
Less than 1, and this one is?
Greater than 1?
Well, it's actually a square, so it's...
Right.
So I went from less than 1 to
1.
1. So the aspect ratio increased when I moved from left to right. Over here, what's the aspect ratio of the view volume? That's this side. What's the aspect ratio of the view volume?
1.
1. And what's the aspect ratio of this guy?
Greater than 1.
So
you get the rectangle.
So no, the aspect ratio increased.
Oh yes.
See, in both pictures, what's common to them is the aspect ratio when you went from the view volume to the viewport, the aspect ratio increased. And that made the oval look this way. Here, I can't show you the view volume. You just have to imagine the view volume. But the view volume is the standard camera volume, which has aspect ratio 1. You went from aspect ratio 1 to an aspect ratio greater than 1, because this is in landscape mode. So the aspect ratio increased from view volume. So as I went from view volume to viewport, the aspect ratio increased. If the aspect ratio increased, you get ovals this way. If the aspect ratio decreases, you get ovals the other way. So I can make the aspect ratio decrease, by doing this one. Now the aspect ratio on this guy decreased because it went from 1 here to less than 1 here. And over here, I can make it by okay. Now I went from aspect ratio larger than 1 to 1. So the aspect ratio decreased from here to here. The aspect ratio decreased from here to here. And here the aspect ratio decreased because I went from 1 to less than 1. Here I went from greater than 1 to 1. Here I went from 1 to less than 1. And I get similar, I get the same distortion, but for different reasons. Now notice that that makes this stuff tricky because you have to worry about the aspect ratio of the view volume and the aspect ratio of the viewport. Now in this program here, I can't control the aspect ratio of the viewport. He's made it so that that's, I think, always a square. Well, no, actually, oh, I can. Yeah, I can. Oh, look, what's up? What do I got over here now?
Nice, the way it should look.
Yeah, because I've noticed I've scrunched this thing into an aspect ratio real close to this one. See, I've managed to scrunch it to an aspect ratio that's real close to that one. So now this one looks okay. It's back to being, I see circles here. So I made this aspect ratio match that one. And here, the aspect ratio here is more of a, and if I go like this, the aspect ratio here is now greater than 1. The aspect ratio over here is less than 1. So it's still like this one. I'm going from a larger to a smaller aspect ratio, so I'm getting scrunched this way. Okay, so as programmers in graphics, we have to worry about aspect ratios both of the view volume and the viewport. Now let me show you some other examples that show this is not unique to 3D graphics. Okay, let me close all these windows for a minute. If you open Renderer 6, there's a folder in it called Aspect Ratio Examples. And this is actually an experiment with, then open this other, in that folder is a folder called Aspect Ratios of Pictures. Okay, this is a demo that's got to do with browsers and pictures, not with 3D graphics. Okay, so here's a picture. It's an old TV test pattern. Okay, okay. What happens when I resize? Okay, notice what's happening here. How would you describe that?
Oh, my screen didn't move yet.
Yeah, Zoom doesn't show resizing of windows.
Pardon me?
Zoom doesn't show you resizing any windows.
You're kidding.
There it went.
Is it frozen or something?
It just went. It's really slow doing that when you resize. It just went to its new size though.
Okay, wait a minute. All right. Okay. What if I just move this window around? What do you see?
It's frozen still. You have to stop dragging or.
You're kidding. Zoom's that dumb?
I think we had this problem before too.
Yeah.
Yeah, I forgot about. Okay, so when I do this, you don't see anything, huh?
Not right away.
Okay, I'm in the upper left-hand corner,
Yeah,
right?
it's there now. It went to the upper left now.
Now I'm in the lower right.
Now it is. Yep.
Took it that long to get there?
Yeah, it's a little lag time. But
Shoot. Okay, you might have to do this at home. Okay, now see, I'm clicking the lower right-hand corner of the browse of Airframe View's window.
yep.
I'm going to just drag it real slow. Is it kind of keeping up with me if I drag it real slow?
No, you know, when you resize, it doesn't do anything. When you drag it around, it kind of just has a little bit of lag. Now it's smaller. But, the resizing doesn't show until you're done with it, I think.
Jeez, I'll have to go look at the movie when this is over and see what's going on. Okay. You see how, okay, what did Airframe View do when I resized that window to an odd aspect ratio?
It's like just clipping part of the picture off.
Yeah, and the word, and actually in picture land, instead of calling it clipping, it's called cropping.
Okay.
And you can even see that if you go up here, image, edit, see they use the word crop. They don't use the word, yeah, everyone's got their own vocabulary. So they, instead of clip things, they crop things. That's what image people call that, cropping. Okay, so rather than taking this image and like doing anything to the image, it just cuts it off. Okay, now watch it different. Now this is an HTML page that loads that picture. Right? So now you see that picture loaded in an HTML page, right? Now watch when I resize it. Okay, it's doing the same thing. I don't know if you, it's doing the same thing that Earthframe View did. See, it's not changing the picture, it's just cropping it. Okay, now let me do a third thing. Open the picture in a browser tab without HTML. So this is the picture displayed in an HTML page. This is just the picture loaded into the browser directly. Okay, so this is just the picture being opened by the browser without any HTML. What does it do now?
Oh yeah, it's resizing it.
Yeah, see, it's resizing it. It's doing a different strategy.
So we can just use the output from the event listener when we're resizing the window
Yes.
to create an aspect ratio.
Yes, yeah, and that's what we'll start seeing code that does that. Yeah, you watch the event handler is doing this. The event handler is resizing that picture to fit the window. Instead of cropping it or clipping it, it's resizing it. But what's interesting is watch what happens when I get to the size of the picture. Can you see what's happening now?
Not yet. Now I can.
What happens now when I grow the window?
It stays its original size.
Yeah, and you get a border. That's
border.
called letterboxing. See, it's switching to a different strategy now. Okay, we're going to see that there's about 5 different strategies that you can do. Now, what we have here is the aspect ratio of the picture is like the aspect ratio of our view volume. It's the source. So that's our source aspect ratio. Then there's the aspect ratio of the viewport that we're showing it in. That's our destination aspect ratio. We want to know what to do when there's a mismatch between the source and destination aspect ratios. In the 3D renderer, the source aspect ratio is the aspect ratio of the view volume, and the destination aspect ratio is the viewport. In this case, the source aspect ratio is the aspect ratio of the original picture, and the destination aspect ratio is the browser window. Okay, now notice that the browser's already shown us 3 strategies. Okay, one strategy is to display the picture in its normal state, surrounded by blackness. That's called letterboxing. Another possibility is to just scrunch the image to fit in, but keep its aspect ratio. So you have to scrunch it to fit it in. Another strategy is to crop it, to keep its aspect ratio and just let it be cut off as you shrink this. Okay. Oh, here's another, here's another strategy. The browser window won't let me close to the left any more than this. Sometimes one strategy is to stop the user from resizing the window. That's another strategy. Don't let the user resize the window. So right now the browser won't let me go any more to the left than that. I can't get, now what about vertically? I can go up, and it's letting me go all the way up to nothing, which is weird, but it won't let me go to the left. I don't know if that's got to do with the menu bars at the top, but see, it won't let me go to the left anymore. If I switch to this other tab, though, okay, say I can't go to the left anymore. And as I go up, I can go up all the way, but it keeps shrinking the image to fit. So the image is not distorted, it just gets smaller and smaller. Okay, that's rescaling and letterboxing. So we've seen several different strategies here. What do you do when the source aspect ratio is not equal to that? Now notice one thing that the Irfan view and the browser won't do is distort this picture. Now browsers will do that if you do things with HTML. So for example, here, the browser will distort an image if you tell it to, but you have to do that using HTML. So if you look at the HTML for this page, this one is number 4. If you look at the HTML, it tells the browser to use a viewport. It uses a browser viewport that's different in aspect ratio from the image, and then when you do that, the browser will distort the picture. And it'll also distort it the other way if you wanted to. Okay, so distort it. Now, if you take this one and resize it, it won't distort it anymore. It just does the cropping now. Oh, you can't see that. See, it does the cropping now. Okay. Irfan view also won't distort the picture. It'll crop it and it'll do funny. It'll do this with it, but it won't make the picture. It won't make these circles ellipses. It won't do whatever you would have to do to scrunch this to make the circles ellipses. Irfan view doesn't like to do that because it's a picture viewer and it doesn't think it should distort pictures. It will chop the picture off, but it won't change its aspect ratio. It keeps its aspect ratio. Okay. Okay, let me show you another example. So notice that this is something. Oh, let me show you another. We just looked at a browser viewing a picture, and we looked at Irfan view viewing a picture. We could also look at Microsoft's photo viewer. If I remember right, it acts different. Okay, here's the photo viewer. See, it acts different than Irfan view. See, here's Irfan view. Irfan view. Can you see what I'm doing? Here's Irfan view. When I make the window small, it does that. Here's Microsoft's photo viewer. When I make the window small, see, now here's the photo viewer. It's actually kind of quirky. At first, it does what?
Does it limit how small you can make it?
Right. It shrinks the picture, so it loses. So the picture changes size. It keeps the aspect ratio, but it changes its size, and at some point, it stops you from being able to shrink it. It won't let you shrink it too much. Think about it. What's Irfan's point of view? See, these are GUI design issues. What's Irfan's point of view? What's their point of view?
Viewport?
No, okay. Why did the Irfan view person decide he preferred it this strategy? I kind of agree with him. What's wrong with this strategy?
You stop the user from getting the. Oh wait, it's hard to see what's going on. Like time, sorry.
Yeah. Irfan view. What is Irfan view keeping constant?
The original size?
Yes. Yeah. I think what he's pointing view is saying you should know how big the picture is. See what happens over here. How big is that picture really? Do I know?
Not anymore.
Not anymore. Now, if I keep growing, it stops growing, and that's its real size. Okay, that's its real size. At some point, I can kind of tell what its real size is. That's the real size. No, it isn't. No, they're not even displaying the same size. Oh, they're not even displaying the same size. Let's see. No, they don't even agree on what the real size of the picture is. So this guy, I think, is he stopped expanding the picture at some point, but at the same time, he expanded the picture up to more than what its original size is. Okay. Notice that this stuff is confusing as heck. If you ever really work with pictures, one big problem is how big a picture is.
Does that have anything to do with the setting on Windows of 125%?
It might. Yeah, that's what I thought the same thing in back of my head. I was wondering if Airframe View and the photo viewer are treating the scaling factor differently. And I'm wondering if they're somehow being goofed up, like, okay, I could do an experiment, turn off the scaling factor and see if they agree now. Ah.
Yeah.
Photo viewer's acting weird now.
Yeah, bounce back to the original size.
Look, it's snapping to different sizes. Do you see that?
Yeah, and then it snaps back to the original.
Yeah, it's all, the photo viewer's all goofed up now without the scaling factor. Airframe View just stayed the same.
Yeah.
And the photo viewer's goofed up now. Good old Microsoft. Wow. Yeah, the photo viewer does not like it when you turn off the auto scaling. This stuff is, if you think this is confusing when you're doing the homework assignments, join the club. This stuff is unbelievably confusing. The designers of the operating systems have not done a good job of building these systems. They're inherently confusing. Graphics is inherently a tricky business, and these operating systems have not really done a great job of dealing with it. And modern technology doesn't help, like with pixel densities constantly changing. You know, one problem is how do you deal with the fact that pixel densities just keep changing and changing and changing? Okay, so now we're seeing that this one is acting very strange now. It's just the window, as I'm resizing, it uses one scaling factor. Then when I'm done resizing it, it switches to a different scaling factor. Airframe View just keeps the scaling factor. It doesn't change the size of your image. As you do this, see, it crops the image or it just keeps the image the same size. Now, some viewers will some viewers will keep the image the same size. For example, here's the natural size of this image. Okay, so there's its natural size. Now I have two questions. When I shrink, what should I do? And when I grow, what should I do? Okay, what are the choices? When I shrink the window, what could happen to the image?
Cropping.
Cropping or
distortion.
Distortion or
you can stop the user from being able to.
Yeah, you could stop the user from even shrinking the window. That's 4. There's a 5th one. You could crop it. You could distort it.
Rescale it.
You could stop the user from shrinking the window. What's another thing you could do?
The rescaling, right?
Yeah, you could rescale it to fit the new window. You could rescale it. No. Okay, now that's all the things you could do when you shrink. What are all the things you could do when you grow?
Letterbox.
Letterbox, which is what Airframe View is doing. You could letterbox.
You could distort it.
You could distort it, or you could
rescale it.
Rescale it to fit the window. Keeping the right aspect ratio. So you could rescale it to fit the window. That's you could distort it, letterbox it, or just keep it constant like this. Now, every program's got to make all those decisions. The easy part is what to do when the aspect ratios match. Okay, here the aspect ratio of the original image and the aspect ratio of the viewport match. What do I do when they don't match? What do I do when they don't match? Lots of choices. What do I do when they don't match? What do I do when they don't match? Okay, Airframe View makes one set of choices. Photo Viewer makes a different set of choices. A browser makes a different set of choices. here the browser is, well, here the browser is acting like Irfan view. The browser here is acting more or less like Irfan view. But when I open this in a browser tab, when I open the image in a browser tab, the browser does not act like Irfan view. Notice that, see when okay, here is the image matching the viewport. Shrink it, and what happens? See? It letterboxed it. It kept the right aspect ratio for the image, but scaled it down to fit in the new window. And if I grow okay, here's where they match. When I grow the window, it doesn't change the size of this. This thing doesn't grow to fit that window. And it could have. It could have made the image grow to fit the window. So it just centers the image in the window. But when I shrink, it letterboxes. Okay? Instead of, like over here, cropping. Notice how when the image is opened in an HTML page, the browser acts one way. And when the image is open raw as the image just by itself, the browser acts a different way. Okay? Lots of choices. And programmers have to start, programmers, this is not just a 3D graphics thing. You can see it's even it's an issue with web browsers. When you design web pages, you have to keep track of all kinds of aspect ratios. Okay.
Do you know what's handling it in the web browser without the HTML? Like if it's CSS or JavaScript or?
No, it's defaults built into the browser.
Oh, yeah.
Yeah. I don't know if you can, that's actually kind of an interesting point. Can you configure Chrome to treat, well, this is actually, right now it's actually open in Edge. Can you tell Edge to act differently when it's displaying a picture raw like that without HTML? When it's like this, it's controlled by the HTML and the CSS. But here it would be, it's just a picture, it's just the image opened in the browser directly. I don't know if you have any control over how the browser handles this or if it's just hard-coded in it. Now, you could also ask, what about a different browser? They don't all act the same either. Oh, whatever. Modern computers. Okay. Okay. There's Firefox opening the picture raw without any HTML. Okay, it's scaling it like Chrome did, and it doesn't scale it larger. It scales it smaller, and it scales it larger. Now, what about the HTML page? Probably all of them are probably going to act the same with the HTML page. See, it crops it. So Firefox is acting just like Chrome did. So Firefox is acting like Chrome. Okay. I have a third browser here. Here's a browser called Vivaldi. Oh, well. This is why Vivaldi you never heard of it. Okay, geez. Okay, so here's another browser. It also does this cropping. Okay. And if you open the image in a tab by itself, it won't let it shrink. This one acts a little bit, well, it lets it shrink. See, yeah, it stops shrinking this way and it stops shrinking this way too. This one stops shrinking at a certain point, but it's keeping the aspect ratio. And when you grow larger, see, it doesn't scale the picture larger. It only scales it smaller. It won't scale it larger, but it will scale it smaller. And that's the same way that Chrome and Firefox did. Okay. And if you play around with enough browsers, you might find one that does act a little bit different. You'll see. Okay, so different browsers, different image viewing programs, they can behave in different ways when it comes time to again, the problem is the aspect ratio of the source versus the aspect ratio of the destination. In a browser, the source would be the image file and the destination is the browser window. In a graphics system, the source is the view rectangle, the view volume, and the destination is the view port. And we have to deal with what to do when those guys don't match up. Okay, now let me show you. I have some other examples here just to show you that what we have to deal with. Okay, here's something that does, here's an example that uses the render. It's similar to your first homework assignment or third homework assignment. Okay, here's a circle displayed on the screen. Okay, when I resize it, it distorts. So this is like your homework assignment. This program does more or less what your homework assignment did. Okay, so that's first example. Now here's another slightly different. Okay, there's a circle. Now notice that as I grow horizontally, I just get a what's called the letterbox on the side, not centered, on the side. Okay, see, I don't want to distort this thing. So as this window grows this way, I just don't use part of the window. Okay, now if I shrink this way, notice I have to keep scrunching this smaller to keep the aspect ratio, and I don't use what's over here. Now if I grow it, it grows to fill up this space as much as possible, keeping the aspect ratio correct. At some point, it's going to be there. Now, when I grow it taller, notice now it doesn't want to distort it, so it has to like not use this space down here. Okay, so now the source aspect ratio is 1, and the destination aspect ratio is less than 1 because it's in portrait mode. So what I do is what I call letterboxing. I don't use part of this space. By not using part of that space, the part I'm left over with has aspect ratio 1. So my source has aspect ratio 1. My destination has aspect ratio less than 1. So I cut off part of my destination, don't use it, and use the part that has aspect ratio 1. But in this case, I put the unused part at the bottom. I could also put the unused part at the top. I could also put the unused part center. Now, if you look at the help screen, it says here, use the 1 through 9 keys to choose a letterbox crop window mode. Okay, I'm in mode 1 now. Here's a different mode. See, what this mode does is I have to unuse some of the space. So all the unused space is the bottom. Here, I centered the image in the unused space. Here, I put the unused space at the top. So those are different modes. Unused space at the top, unused space at the bottom, unused space centered. Okay, this is the more common way to do it. Okay, and then if I stretch it this way, so the unused space is on the left. Well, again, there's actually several different modes. The unused space can be on the left, it can be on the right, or it can be centered. See, there's the unused space is split between the left and the right. There are the unused spaces on the left. Okay. Notice that there's all these. Now, any given program can use any one of these strategies. You know, the most common strategy is to do this. Okay, now notice that there's my left-right strategy can be different than my horizontal strategy can be different than my vertical strategy. Like right now, my horizontal strategy is centering. Okay, what's my vertical strategy? Put the space on the bottom. See, see, I have a strategy now where the unused vertical space is at the bottom, but the unused horizontal space is centered. Okay, some programs do it this way. They switch this is switching letterboxing mode. They letterbox on the horizontally on the left and right, but they letterbox vertically, say only on the bottom. So there's all these different modes. Like let's say I just switched mode to something else. Okay, here letterboxing vertically is on the bottom, horizontally is in center. See, horizontally is centered, but vertically is on the top. The extra space is on the top, the image is on the bottom. Okay. Now the code for all these different modes is in the program. Later, another day, we'll look at the actual code. It's all in the resize handler. The resize event handler is the one that's juggling all this. Okay. Now that's letterboxing. Here's cropping. Now, what does that mean? When I shrink, I just cut off part of the picture. See? So the strategy now is, if it shrinks, cut it off. Now, what if it grows? Just leave it where it is. See? So if the window grows, I leave this guy where he is, and I have this unused space on the left and right. Okay? So crop it this way. But on the other hand, that unused space doesn't have to be on the left and on the right and the bottom. That unused space could be like here, the unused space is split on the left and right, but it's all on the bottom here. In this mode, it's on the left and on the bottom. Here it's centered vertically, but on the right on this edge. So it's centered between the top and bottom edges, but it's aligned on the left edge. Here it's on the top edge, on the right edge. Here it's on the top edge, but centered between the left and right edges. Here it's bound to the left and right edge, the left and top edges. There's 9 of these different modes. This is the one where everything is centered. It's always centered. Okay. So I gave this program 9 different ways of centering this image when it's not cropped. When it is cropped, it's always the same. Oh, no, actually, it's not the same. Here, even the cropping is a little bit different. Okay. Okay. The viewport matches the picture, so there's no problem. Now I shrink the viewport. Tell me how many different ways there are to crop the image when I shrink the viewport.
Probably the same number.
Yeah, what's this one doing? It's cropping, but what's it doing?
Mine hasn't changed yet. There it is.
I'm sorry.
Staying centered.
It's staying centered. It's cropping, but staying centered. Now, the other mode did this. I started cropping, but
Yeah, right and bottom.
I'm cropping from the right and the bottom, and I'm keeping
The upper left
in place. Yeah. The upper left is being kept in place, and the lower right is being cut off. Notice that the center is, I'm not keeping the image centered. See, I cut off the center there. So that's one of the modes. Yeah, and the other mode was like, this was the mode that kept things always centered. Then there's a whole bunch of modes in between. Like here's a mode that crops from the left and evenly on the top and bottom. This is a weird mode. What this does is when you shrink, it keeps the right edge. See, this right edge will stay there all the time. And when I shrink, that right edge stays there. It crops from the left edge, but the top and bottom edge are balanced. Writing all this code was fun. And do you have to, if you're actually going to do web design, if you pay attention, you'll see that all of these modes are buried in the cascading style sheets. There are styles for all of these modes, okay? And it's one of the things that makes cascading style sheets kind of a big stinking mess, because it's trying to deal with a lot of these weird things. People want this kind of control in their styles, so they're buried there somewhere. Most of the time, people never use them, but if they ever do need them, they're there, okay? Now, in these programs, all the different modes are handled by a little bit of algebra. See, here's the different mode. Mode 1, Mode 2, Mode 3, Mode 4, 5, 6, 7, 8, 9. It's a little bit of algebra of controlling the viewport and the camera. Notice that I have to get these different modes, I actually juggle both ends of the problem. I juggle the viewport side and the camera view volume side. It's a juggling act between the two of them. Okay, you have to get these different modes. You do something to the viewport, that's one end of the pipeline, and you do something to the camera volume, which is the other end of the pipeline. And if you juggle the two ends of the pipeline just right with a little bit of algebra, with these little bit of formulas, you get all these different modes. Okay, figuring this out was not easy. It's, you just have to kind of, I don't know which is better, doing it yourself and just forcing yourself to figure it out, or reading my code and seeing how I did it. But you can go through and you can see like what weird little things I had to do to make these. Like here, I should have commented these. Like this says upper left-hand corner. This keeps the image, this crops, so we're doing cropping. This crops with the other left-hand corner always fixed. This crops with the image always centered on the top edge. So the image is cropped, but it's always centered on the top edge. This one crops with the image always in the upper right-hand corner. So let's see, let's check. So that's supposed to be 3. So let me switch this guy to mode 3. Now it claims that mode 3 is upper right-hand corner. So I should see this part never move. But as I crop, see, this quadrant up here is not changing. I'm cropping from the left and from the bottom. The upper right-hand corner stays fixed. So the upper right-hand corner. Now, mode 4 was centered on the right edge. So let's check mode 4. So mode 4, it's centered on the right edge. So as I now start cropping, you should see this line stay fixed, centered on the right edge, and it should crop around around that. See, if you can see, this guy's staying, this line here is staying fixed. This thing's fixed on the center of the right edge, and everything around it's being cropped. So that's mode 4, centered on the right edge. Okay, and centered on the right edge. See, there's the formulas for setting the viewport, and there's the formulas for setting the view volume. Okay? You won't find these in books. Books just wave their hands and say, books will say, you can do this, and then they'll give you some homework problems to try to do it. But here, what I did, I tried to catalog pretty much, I think, all the different modes you could do. I don't think there are any other ways you could do it besides these 9. It's kind of, it's really interesting. If you ever are working with HTML or other GUI systems and you have to worry about this stuff, Yeah, here you can kind of see one way of handling it. Now, this is a 3D system. So if I was doing actual pictures like Irfan view, the code wouldn't look like this because there is no view volume when you're viewing pictures like an Irfan view or photo viewer. There is no view volume. Okay, so in those cases, if you're doing the same tricks but with pictures, things would be a little bit different over here because there is no view volume. There's only the viewport. So you'd have to do, but there's also scaling the picture. So you would have to worry about the viewport. In place of the view of this view volume, you would have to work with code that scaled the picture, okay, which is actually a little bit trickier. So you'd be adjusting the view volume and scaling the picture instead of scaling the view volume. You'd be working with the viewport. You'd be setting the viewport, but instead of setting the view volume, you would be scaling the image. Okay, all right. Now, how does so now the next question is, what does the renderer do to give us this feature? The feature is a adjustable view volume, okay? And that's render 6. So if you look at the README for render 6, it tells you what's new. What it is essentially, it's an expanded camera class. Okay, so the camera class has been expanded, so the camera now keeps this data in it. So the camera records what its view volume is, what its left, right, bottom, and top is. If you go back one render to render 5 and look at the camera stored almost nothing. Back then, the camera only had a Boolean value, said, I'm a perspective camera or an orthographic camera. That was it. The camera was nothing but a Boolean. Now the camera is a whole lot more. Now the camera is that same Boolean, and now it's a left, right, bottom, top, near. Okay, just like in those demo programs we saw. So now it's doing the left edge, the right edge, the top edge, the bottom edge, and the front plane, the near plane. Those are the 5 parameters along with this thing. Okay, and then you have to have code for setting those things. Okay, now one thing is, not everybody likes to do this by saying what's the left, right, bottom, top. Okay, you could also use something called the field of view and the aspect ratio. The best way to do that is to look at the demo program again. If you look at this one, the code over here, okay, there's the demo program on the left, and this is the camera code on the right. Okay, this is OpenGL, and I mimicked OpenGL in this code over here. So see this projective perspective? Yeah, see perspective, field of view Y, aspect near. Field of view Y, aspect near. I don't have a far view, okay? So this is one way to set the view volume. What this does is it changes the angle between the top and the bottom. This is the angle between the top and the bottom. And then this changes the aspect ratio of the front rectangle. Now, that's opposed to this other method that I called, well, actually, I gave them both the name perspective, but they're overloaded with different parameters. If you go over here and right-click, it's the Frustrum method. Okay, then it's got left, right, bottom, top, left, right, bottom, top. So the code over here, our library mimics the OpenGL library. So I did that so that it would be a lot easier if you're transitioning from this to this. I used I didn't use their names, but I used their parameters. Okay, so you can control the view volume 2 ways: by left, right, bottom, top, or by angle and aspect ratio. Angle and aspect ratio. See, now the aspect ratios are larger than 1. That's the That's the landscape view. Here's aspect ratios less than 1. That's the portrait view. You can barely see the aspect. Yeah, you can barely see it over here. Okay, we ran out of time. Okay, so on next week, we'll look a little bit more carefully at the code for render 6. What it's going to do is it needs one more pipeline stage to use these numbers. So there's going to be a new pipeline stage. This pipeline stage here, view to camera. That pipeline stage uses those numbers to control the shape of the view volume. Okay, so we'll look at the code to do that on next Tuesday. Okay, all right. And read the README. The README tries to explain this. Okay, the README tries to explain this. Yeah, so it's got a discussion of, oh, there's the new pipeline stage. It's at the front of the pipeline. Okay, so okay, and down here are, we talk about these different strategies. Here's where I try to describe the different strategies for you. What do you do when you mismatch the view volume with the viewport aspect ratio? So I tried to explain the different strategies. So read about those different strategies and play with all the demo programs. There's a ton of demo programs with this render. So render 6 comes with a whole bunch of demo programs here and here, okay, that you can play. And it includes playing around with the browser and Earthframe View and Photo Viewer. They're all versions of this stuff about different aspect ratios. Okay, so we'll go ahead and quit there. Okay, and if you have questions about render 6, and I'll try to have a new programming assignment up pretty soon. And I'm going to try a programming assignment that hopefully uses, I want it to be a programming assignment that uses these ideas here for you, so you can play around with this stuff here yourself. Okay, actually, I think what I might do is let you add these features to the last programming assignment. The last programming assignment didn't do anything. The last homework assignment just did the naive thing. So it'd be nice if you give this programming assignment the ability to do this with the. We'll see. I'm not sure if that's easy, or how. I have to first figure out if that's difficult or if that's pretty straightforward. Okay. All right. So go ahead and quit, and have a nice weekend. And if you have questions, send me emails. And otherwise, we'll meet again on Tuesday. Bye.
Right.